has amazing reaction time skills. So when he sees the dart leave the blowgun, at that instant, he lets go of the branch. So he's going to start falling too. Now the question is, if the dart comes out of the gun, bore-sighted at that bullseye, and the monkey lets go at the instant the dart comes out of the gun, will the dart still hit the bullseye? Or will it go higher or lower? What do you think? I see one hand, 2, 3. Mr. Jordan, what do you think?
I think higher.
Okay. Why do you think higher?
Because the bullet is going at a, you know, it's being forced at going up, and the monkey
It's
has
fired
no other,
up at an angle, not
yeah,
horizontally.
Yeah, and it has a, and the monkey has no other force acting on it but gravity.
Okay. Thanks, Rex. Yeah. She's here, finally. He's here, taking video. He's here. She's here without her cast. She's here making the exercise my classroom management skills, and he hasn't spoken a word today. They're all here.
Hi, Rexy.
Rexy?
Sexy Rex.
Oh God.
Okay, so Kevin thinks it's going to go high because initially the dart is projected up at an angle. Aiden, what do you think?
And as long as it has enough speed to get to the place where the monkey will
Agreed.
hit the ground.
Let me reiterate what he just said. Obviously, the hunter has to blow the dart out fast enough so that it makes it over here, right? It can't just go out like that. Obviously, it won't hit the monkey then. So this assumes that he's blowing hard enough that the dart actually makes it laterally to the tree. Okay, so go ahead.
There's no way you can miss.
No way he can miss. He says with confidence, but without any explanation for why.
Why? Because if he shoots it just hard enough to get right there, then it'll go on exactly halfway up the height of the tree, height of where the monkey is falling from.
Uh-huh.
And by that time, the monkey will be exactly halfway down.
Okay, I think you're implying something, but you haven't come out outright and said it. And maybe it's just so obvious to you and me that you don't think you have to say it. Yes, sir?
Well, the dart and the monkey falling are being acted upon by the same force, and that's negative 9.8 newtons.
Well, they're both acted on by the same force, which is gravity,
Yeah, gravity.
which causes them
Yeah.
to accelerate at negative 9.
And if the dart is pointing towards the target and the monkey, and at the same instant they're dropping, then regardless of where they are, the force is the same, so they should meet.
Okay.
I mean,
Okay, so this, let me reiterate, or say in different words what he's saying. He's saying the upward motion of the dart initially doesn't matter,
yeah.
because they're both free falling. Okay, is that, am I saying?
Yeah, no, you're right.
Okay, so Kevin, he's disagreeing with you. Okay.
All right.
All right, Lindsay?
Well, this may be totally wrong, but isn't it kind of the same concept as the bowling ball with the car? How like it's the same.
Well, the bowling ball in the car was more about how the bowling ball was turned into a projectile, but its forward motion didn't change.
Yeah, but what I'm saying is it's gonna fall at the same time.
Okay.
So
Yeah, I probably wouldn't link it to that
No, it's
particular
not.
demonstration, but, I mean, it's projectile motion, but, okay, Kara?
Is the parabola of the projectile, is it gonna peak where the monkey is right now, or is it gonna
Oh, it'll peak, well,
like, did he
um,
aim below?
well, obviously, the dart will not reach that high, so yeah, it's gonna peak before it hits the monkey. Does that matter?
Yeah.
Okay, you think it matters? Izzy?
Somebody already asked this question, but just to make sure, the dart is being blown at the right rate so that it stops exactly in the monkey's line, right?
Yeah. Yeah, it's not gonna miss him laterally. Okay, okay, so I wanna take a vote now, but I don't want you to vote with any peer pressure. So I'm gonna ask you to close your eyes in a moment and respond to one of these. You gotta vote. Either you vote that you think that the dart is gonna hit high, higher than it's aiming for, above the bullseye. You think it's gonna hit low, below the bullseye, or you think it's still gonna hit the bullseye. Okay, those are your three choices. Close your eyes. Would you raise your hand if you think that the dart is going to hit higher than the target? Okay, thank you. Would you raise your hand if you think the dart is going to hit lower? Thank you. Would you raise your hand if you think it's going to hit right on? Okay, thank you. All right, so here's how the voting went. 2 people said it would end up higher. 2 people said it would end up lower. And I think everyone else voted and said it was going to hit right on. Now, you know how it is in here. Usually, your intuition is right or wrong.
Wrong.
In this case, you're right. Okay, so if you said it hits right on, you're right. I'm going to show you that in just a moment. But first, let me tell you the way that I would explain this. First of all, let's turn this off. All right?
What?
Well, this is the gravity switch.
Uh,
Okay? So let's turn off the gravity switch, and now gravity is off. Right? So it's really easy to see what's going to happen. The dart gets blown out of the gun, and Kaylee, it's going to follow that path. And it won't bend into that parabolic arc because there's no force of gravity. What does the monkey do? He lets go, and he hovers. There's no gravity to pull him down. He gets nailed. So let's change things now. What happens if we turn gravity on? Well, if we turn gravity on, then these are both going to be affected by that gravity. They'll both start free falling. Even though this one's traveling in an upward path, it's still free falling. Let's put some numbers to it. Let's say it takes 1 second for the dart to make its way laterally over here. Now careful, don't answer incorrectly. How far will the monkey drop in 1 second? You want to say 9.8, don't you? No?
The same distance?
No, give me a number. In 1 second, how far will the monkey drop?
10 meters.
That's like 9.8. You want to say 9.8, don't you?
Yeah, it's lower than where we're
Okay, here's
5 meters.
how you can figure it out. This is 0, isn't it? The monkey starts off with no velocity. He drops from rest, so that term just goes away. 1/2 AT squared. That's negative 9.8. That's 1 second. Squared is still 1. So 9.8 times a half. He's going to drop 4.9 meters. So in 1 second, we have the monkey dropping 4.9 meters. I can't deal with it right now.
Should I just leave it?
Yeah.
Okay.
So, and Early, can you edit out that little intrusion?
Maybe.
Okay, so the monkey will be down here. Now listen to my words. Listen to the way I'm forming this statement. The monkey, in 1 second, will drop 4.9 meters from the place where it would have been if gravity were off. What happens to the dart? Well, it's affected by gravity in the same way. It's free falling. So the dart will fall 4.9 meters from the place where it would have been if gravity were off. Gravity's not off. And so it will have to, yes, initially go upward, but it's being pulled on by gravity, and it will also drop 4.9 meters from where it would have been if gravity were off.
Why would
So-
it have been there?
What's that?
Why would it have been there necessarily?
Well, in 1 second, I'm saying in 1 second it takes that long for the dart to move across. Okay, so let's give it a go. All right, come with me. Okay, so you can be kind of here or in here. Any place is good right now. Aiden, you're good right there. But I need someone over there. So Kevin, that stool's a good place. Oh, that's good. You can. It's a little dangerous. Okay, stop talking. Stop talking. So, Kevin,
Yeah.
in front of you, there is a switch on the power supply. Would you turn it on, please? Okay. So this is one big circuit. Where are you, Early? Oh, there you are. This is one big circuit, and the circuit's complete when these two wires get touched together. I'll have Sarah hold these two together. You're worried you're going to get a shock, aren't you? You won't. Trust me. No, right there. Yeah. Hold those two together. Ah, okay, so the circuit is closed, and that means that that electromagnet is creating a magnetic field. So that's going to be our tree. And here's the monkey. As long as those two wires are connected, the monkey's magnetized to the tree. Take those two wires apart. Okay? So as soon as the circuit's broken, the magnetic field's lost, and the monkey drops out of the tree. So, Sarah, thanks, but I'm not going to have you. Do that anymore. I'm going to hook these up to the blowgun. And if you're smarter than the average physics student, you kind of know where this is going. Are you smarter than the average physics student?
Yeah.
Half of you are.
Maybe.
No, this is one of my higher performing classes, so more than half of you are. So that circuit is hooked up again because that bracket connects those two wires together. So I can put this up here, and he will just stay there. Uh-oh.
No.
Is the power supply on? Still? Uh-oh. Okay, turn that off for a minute. So we must have had a bad connection somewhere. Now, there's a weak part in this circuit. And the weak part in the circuit is right over here. There's a little flap of metal on the top of the blowgun. So the dart is really going to be a little ball bearing. And when the ball bearing comes out of here, it's going to lift that little piece of metal up. And as soon as the ball bearing comes out of there, the monkey's going to start dropping. So can you see that this is just like what I posed over there? I hope you can see that. So we're going to put it up again, the monkey, which is getting really banged up. But that's what happens when you fall out of trees and get hit by poison darts a lot. No. You're thinking the ball's going to go over there?
No, I'm thinking that's gonna
It's
be
gonna-
right in front of Kevin's face.
There's a little
Yeah,
stretch.
but it's going to be coming back at you. It's going to reflect back at you.
Oh.
So can you catch it, please? Thanks. All right, so remember I've got a bore sight. So I'm looking through the bore. And it looks good. And now, you're not going to have to catch it.
ready.
You're not going to have to catch it. It's
I
going to
hope
bounce
not.
off of the monkey.
I hope not.
Do you trust me?
But the
Yeah.
monkey might hit it. I didn't trust you when you did the, is it the capacitor
Oh.
on the morning.
Okay, so I don't know if you noticed, but I kind of held the flap down when I put the ball bearing in so I didn't break the circuit. All right, here we go. I'm going to leave this up for a few days so you can try it. And if you're going to try it, you should try it soon, because right now the only DNA on there is mine.
Not when I get some lab DNA.
Ready?
That's dope.
Nailed it.
Got it.
Good, sir.
Got it.
Good try.
Okay, Kevin, let's do a replay on that. We put that back up.
Can we do that again? That was so cool.
That's why I said let's do a replay.
Those times.
That was so cool.
Really?
Kevin,
Where's
I
that?
worked it. Come on.
Was that? Was I supposed to say the A word? I'm scared of saying it in your class.
No, it wasn't awesome. It was really cool.
So I got it right.
There you go. Nice job.
Yeah.
All right, and now I'd like to say that I can blow it at any speed, but it turns out that if I blow it too slowly,
I'll get there.
there's enough air resistance, that goes up through the bottom of that can that the can actually slows down. So I do need to blow it kind of quickly so air resistance isn't a factor. All right, here we go.
Oh, I'm so good.
Always happens.
What is it?